Okay, Assalamualaikum. Alright, today's topic is the third part of reinforced concrete beam design to Eurocode 2, which is on the serviceability limit state. We have to check for deflection and also cracking. Okay, so for the course and program outcome, it will be in line with CO2, PO3. And the learning outcome, at the end, you should be able to understand the definition of cracking and deflection of beam. And then you need to check the cracking and also you need to check deflection of the beam. So in complete beam design step, this is step number 7 and step number 8. And the first one is the crack control. For crack control, we are referring to clause 7.3 in the Eurocode 2, and the recommended value of crack is given in the national annex is depending on the exposure classes and is given interval 7.1n. To ensure that maximum crack width does not exceed 0.3 mm, EC2 recommend the minimum reinforcement necessary to control cracking. It's based on the table 7.2n and also table 7.3n. Okay, so this is table 7.1n. So in the appendix is in page 16. Okay, so based on your exposure class condition, let's say your exposure class is XE1, then you use the crack width 0.4. Otherwise, for other type of exposure, then you use 0.3. And then you refer to table 7.3n. So from here, we have the crack width 0.4, 0.3, and also 0.2. So the value here is actually the maximum spacing, S maximum. And here is the steel stress. Steel stress is given as the formula here in the appendix page 50. So this is actually the value of steel stress. So based on the value of steel stress that you get here, and then you are going to get your maximum bar spacing. Okay, and if if the value is not an exact value, for example, let's say here you get your value is 2220, then you have to interpolate between these two numbers. So depends on your column. Okay, for example, let's say example number 1, let's say we have a clear distance between the bars. So then this spacing check is after you have designed your main reinforcement and then you get your arrangement. For example, here they are going to provide 3 number of reinforcements. So here is 3 bars, and then you have link. And if you want to calculate the value, the spacing should be less than S minimum, but the spacing should be greater than S minimum and less than S maximum. S minimum is given here, the diameter bar, the diameter aggregate plus 5 and 20 mm. So this is your S minimum value. This is your spacing requirement, actual spacing. Then you calculate for maximum spacing. First, calculate your Fs value from this equation. You just substitute the value of Gk and Qk value. The value of Gk and Qk is the value before you factored. So means it is unfactored value. And you get your Fs value. And then based on the table 7.3n, for crack width, for example here, crack width 0.3. Then you get your S maximum value equals to 50. Then compare with your actual spacing, which is 32.5, which is less than 250. Then you have to, it means that our crack check is passed. Okay, so that is for the crack check, and then we check for deflection by referring to clause 7.4 in Eurocode 2. So for deflection, it is just similar to the one that you have done in slab design. So which is we have two equations here, and we choose based on our rho and rho naught value. So rho is actually AS required divided by BD. So let's say you have double reinforced. So means you have AS prime at the top and AS at the bottom. So for AS prime, you have rho prime. For single reinforced, it means that you don't have the rho prime or AS prime. So you just take the value of rho prime equals to 0. Okay, and then you refer to table 7.4n, and for the K value, depending on the type of the beam that you have designed, simply supported or the end span or the interior span. And then you calculate your modification factor and times with the L over D basic value just now, and you get your allowable deflection, L over D allowable. And the L over D basic is modified if your span is greater than 7 meter. If the span is greater than 7 meter, then you need to modify your L over D basic times with modification factor and then times with 7 over span. Or you are going to design flat slab, then you need to multiply by 8.5 divided by span. And if the characteristic strength is greater than 500 Newton per millimeter square, then you have to multiply by 500 divided by FYK value, and also the modification factor. Okay, so let's look into one example. So here it's given that the AS required is 945 and the provided reinforcement is 2H25 or 982 mm squared. And this the reinforcement is provided at interior span. So for interior span, it means that K is equals to 1.5. And also given here, the span of the beam is actually 10 meter. So which is at 7 meter. Okay, so first you calculate your rho value and compare with rho naught value. So you get that the rho value is less than rho naught and the K value is K5, 1.5. Then substitute into the equation. So you get your L over D basic. And then you calculate your modification factor. So the modification factor is 1.04. And L over D basic is multiplied by modification factor, multiply with the 7 over span since the span is greater than 7 meter. If your span is equals to 7 meter or lesser than 7 meter, then you can ignore this equation. Okay, so then you calculate your L over D actual, compare with the allowable so that you get your deflection is certified. Another example, for this one, we have continuous beam with span of 7 meter. And given here is as required 3H25 as provided. And the beam size is 250 times 400. Okay, and the reinforcement is provided at end span. So end span means K equals to 1.3. Okay, so you calculate your rho value and rho naught value. Since the rho value is greater than rho naught, so you are going to use the second equation. Okay, so from the table, you get your K value equals to 1.3. And since here it does not give you your AS prime, so means it is single reinforced. So means that the rho prime value is equals to 0. Okay, so you substitute into the equation, then you get your L over D basics, and then get your modification factor. So make sure your modification factor is less than 1.5. Okay, so you times with the L over D basic So here you don't need 2 times V7 over span because the span is equals to 7 meters. So this one is ignored. So you get your L over D allowable and compare with L over D actual so that you get the deflection is satisfied. Alright, so that's all. Thank you very much.